Today we're going to look at the fundamental counting principle, and we're going to look a little bit at compound probability. Everybody should have the sheet that you see on the screen at your desk. Put your name on it. Okay? Now, we're going to work on tree diagrams first. And it's important that you draw your tree diagram just as I draw mine, because you will see these more than likely on your milestones. The tree diagrams are, I would say, the more complex way to figure out the outcomes in a probability experiment. That's what you're doing, trying to figure out the number of outcomes. So we're not solving for probability. We're not writing a fraction. We're looking for how many outcomes. For example, if I'm going to roll a number cube numbered 1 through 6, how many outcomes are there? 6. If I'm going to roll a number cube numbered 1 through 10, how many outcomes are there? 10. So today we're working on some outcome questions. We're not doing fractions and stuff, okay, right now. So we're kind of switching gears a little bit here. All right, so the first question on your sheet says, you go to the snack bar to buy a bagel and a drink for lunch. You can choose from a plain bagel, a blueberry bagel, or a raisin bagel. The choices for a drink include water or a sports drink. How many different lunches could be made with these choices? Now this is small enough that you can do just some mental things and figure it out. But we're going to draw a tree diagram of this information. Alright, so how many bagels did we have at the beginning?
3.
How many bagels? 3. What were they?
Plain bagel, blueberry bagel, and a raisin.
Okay, so we're going to do a P for plain, a B for blueberry, and an R for raisin. P for plain, B for blueberry, R for raisin. Okay, now, let's say I have a plain bagel. What am I going to have to drink with that plain bagel? What are my choices? I could have water, or I could have what? Sports drink. So, that's 2 combinations. I could have a plain bagel with water. That's 1. Or I could have a plain bagel with a sports drink. That's 2 combinations so far. 2 lunches. You understand that? Okay, next, what if I get a blueberry bagel? What can I have with a blueberry bagel to drink? Water or sports drink? How many combinations?
2.
So now we're up to what total?
4.
4 combinations. Okay, what if I get the raisin bagel? What can I have to drink? Water or sports drink? How many total different lunches can I have?
6.
There's 6 lunches. And the way you count that is by counting your outside branches. 1, 2, 3, 4, 5, 6. That's 6 different lunch combinations. Plain with water or plain with sports drink. Blueberry with water or blueberry with sports drink. Raisin with water or raisin with sports drink. That's 6 combinations. Now, the fundamental counting principle, we're going to call it FCP, keeps you from having to draw a tree diagram. Because as we get situations that are longer and bigger, let's say if you go to McDonald's, you have a choice of Big Mac, cheeseburger, a quarter pounder, fish sandwich, chicken sandwich. They've got maybe 13 to 20 sandwich choices. We don't want to list all 13 to 20 sandwich choices. Then you got fries you could have with it. You've got fruit that you could order if you're a kid. You've got a small fry, medium fry, large fry, super size. Okay? Or you could get nuggets. So as the situations get bigger, your tree diagrams can get really, really, really big. And when the tree diagrams are really, really big, we get frustrated because it gets crowded and hard to read. So thank goodness that somebody, and I don't know who that somebody is, invented the fundamental counting principle. And what you do is you look at your situation. We have two categories. We have bagel category and we have a drink category. And it sets that up right here. Bagel, drink. How many bagel choices did you have? That's a 3. So you put a 3 down. And we're going to multiply. There are 3 outcomes for bagel. How many outcomes for drink? 2. And 3 times 2 is? So 6 total outcomes. See how we got there? A lot quicker than our tree diagram. Okay? Let's go to another situation. Number 2. This is what you do, kind of, when you get ready for school in the morning. Except we don't lay out everything and go through all the possible combinations. We kind of say, oh, that looks good together. This looks good together. Okay, let's go. All right? It says, when you get ready or get dressed for school, you open your closet to find that you have the following choices. A red, blue, or white shirt. Jeans or sweatpants. Tennis shoes or sandals. How many different outfits could be made with these choices? Okay, so what are we going to write down first on the sides? R, B, and W. Okay? Now, let's say I choose the red shirt. Red shirt with what kind of pants? So I could do jeans, or I could do a red shirt and sweatpants. Am I done? What am I missing? The shoes. Let's say I do red shirt, jeans, and then what kind of shoes? Tennis shoes. What's the other kind of shoes? I could do red shirt, jeans, and then sandals. Let's see how many outfits that would be so far. Red shirt, jeans, tennis shoes. That's one outfit. Red shirt, jeans, sandals. That's 2 outfits. Now, let's say I do red shirt, sweatpants. What kind of shoes? Tennis shoes. That's a 3rd outfit. Red shirt, sweatpants, and then sandals. That's the 4th outfit. Woo! See how complicated it can get? And if you're a girl, we can do like jewelry, earrings, headbands, bows, curly hair, straight hair. I mean, we can keep going on and on. Lipstick, no lipstick, mascara, blush. Okay? We can keep going. Okay, let's go to the blue shirt. Blue shirt. So we can have blue shirt with what? Jeans and sweatpants. Blue shirt, jeans, and tennis shoes or sandals. Blue shirt, sweatpants, and tennis shoes. Blue shirt, sweatpants, and sandals. Good. Okay, now white shirt. White shirt. What? White shirt. White shirt, jeans, and tennis shoes. White shirt, jeans, and nope, sandals. White shirt, sweatpants, and white shirt, sweatpants, and sandals. Now, how many outfits did we get? Count up your outside pieces. How many? What'd you get? 12 combinations. You get 12 combinations. This is the first one right here. This is the first, second, third, fourth, fifth, sixth, seventh, eighth, 9th, 10th, 11th, and the 12th. There's 12 combinations. Now let's do FCP, fundamental counting principle. What's my first number? I have 3 shirts, that's 3. How many pairs of pants? Pants, 2 pair of pants. Jeans or sweatpants. How many pairs of shoes? 2. To see how it's categorized, shirts, then your pants get a number, your shoes get a number. See how that category works when you read it? Okay, what's 3 times 2? 3 times 2. And then 6 times 2 gives us 12. Okay, flip over. Let's go down to question 7. Question 7. You wake up in the morning and you go to the pantry to look for breakfast. You have a choice of Pop-Tarts, muffins, granola bars, or cereal. To drink, you have a choice of whole milk, 2% milk, skim milk, orange juice, apple juice, and water. Your mother insists that you take a multivitamin with your breakfast. You can choose from good old Flintstones, one-a-day vitamins, or chalks. How many different breakfast combinations can we make? So we're using the fundamental counting principle. We're not drawing it out. Okay, we're not going to draw it out. So what's our first number?
4.
Why 4?
4 cereals.
So we get Pop-Tarts, muffins, granola bars, or cereal. That's 4. Okay, times. What's next? What's our next category? What's our next category? The drinks. How many drinks do we have?
6. 5. 6.
We have
5.
whole milk, 2%, that's 2. Skim milk is 3. Orange juice is 4. Apple juice is 5. And water is 6. 6 drinks. Times. What's our next category?
3.
Okay, what's that consist of? The vitamins. Flintstones, one a day, and chalks. That's 3. Okay, now we multiply this out. 4 times 6 is 24, and 24 times 3 is 72. See how that works? Number 8. You go to Walmart to buy batteries. You can choose from Eveready, Duracell, or Rayovac. Once you decide on the brand, you then have to decide whether to get alkaline or non-alkaline. Finally, you must decide between AAA, AA, C, or D batteries. How many different kinds of batteries are available for you to buy? Okay, so 3 times 2, because we have alkaline or non-alkaline. And then 4. 3 times 2 is, and 6 times 4 is? Number 5. You go to the home electronics store to buy a new television. You have the following choices: rear projection, LCD, DLP, CRT, or plasma. How many? Next, full screen or widescreen. How many? Next, 13-inch, 19-inch, 27-inch, 32-inch, 36-inch, 41-inch, 51-inch, or 63-inch. 8. All right, 5 times 2 is, 10 times 8 is 80. How many outcomes are on a penny?
2.
Okay, so let's look at number 6. If I toss a penny the first time, how many outcomes? It says I'm going to toss it 4 times. If I toss the second time, how many outcomes? If I toss the third time, how many outcomes? If I toss the fourth time, how many outcomes? So now I multiply. 2 times 2 is, 4 times 2 is, 8 times 2 is,
16.
you can't go like this, 2, 4, 6, 8. Now numbers 1 Numbers 3 and 4 are easy because they give you the numbers to multiply by in the problem. I'm not worried about those. When they give you the numbers, all you got to do is write them down and multiply them. It's the ones where you have to read and come up with the numbers that you need to know how to do. Okay? Any questions? No? Okay. On Canvas, lesson 6. Go to Canvas, lesson 6. We're on our probability unit. So we're going to Canvas, lesson 6. On lesson 6, you're starting here on finding the number of outcomes like we just did. You stop at a score of 80. Don't go above 80 because if you go above 80, it gets too complicated. Stop at 80. You have these 3 things to do that all deal with fundamental counting principle, and they go very, very quickly. They don't take long at all. Use a calculator. Go.